bit more radical on where we choose to land. In particular, we probably want to choose one safe site that's flat, easy to land on. We're 100% certain. But if that landing works, we can go to some pretty rugged sites if we want to. And well, if we lose one, we still have a mission. We don't lose any astronauts. We don't even lose any science time because they'll explore one of the other missions. Let's see. There's a lot of planetary protection issues with humans. Humans are biologically icky. Planetary protection is easy with HERRO. I think I should zoom across a little bit faster because I think I'm running out of time. We can also explore other dimensions. I'm very interested in the moons of Mars. They'd be a very interesting thing to explore with humans.
Is there really a big pool hall inside Phobos?
I think we need to go there to find out.
It's the same thing Zubrin said.
Yeah, I think we need to go there to find out.
There is some evidence now.
Yeah. I think there are ice cubes inside Phobos, so I think we should, at least bring martinis. Cost is going to be cheap, so let me just zoom right to the conclusions. Say, exploration of Mars by telerobotics is definitely possible. It may be a low-cost first step for a human mission to Mars. So thank you for paying attention. I ran out of time, but there's nothing after this session, so stay as long as you want, I guess.
He's the last speaker, so we can take a little more time.
Okay, let's start in the front and move clockwise. Here.
Yes. Does Robonaut have feedback so that you could feel what it feels?
Yes. The feedback isn't that great, but it does have feedback, so you can feel whether you're moving or not. So it has first level haptic feedback.
For the solar arrays there on the truck, I'm assuming that's articulated so that
yes.
As the winter comes, you don't have to
Yeah.
find a slope to park on.
Yes.
You can,
Yeah.
Could you use it as a sail?
Probably not. It's an awfully thin wind. People have proposed wind-powered systems on Mars, but I'm kind of dubious. Yeah.
It seemed to me like it would make more sense, really. You've got a lot of investment here. Just put a base on Deimos or Phobos and do all the rest of the stuff from there.
Yeah, we've gone back and forth over whether we want to actually go on to Deimos and Phobos and whether it helps or hurts. Phobos is in a low equatorial orbit. Deimos is in a little bit higher equatorial orbit. The problem with Phobos is, of course, you move pretty fast, so you're not over one site terribly long. Deimos, you're over a little bit longer, but it really restricts the number of sites on the surface you can do. You need the ones you can see from
You've got a
Phobos.
radio. Let your relay move, and you stay there.
Yeah, communication satellite.
What you just said doesn't matter.
It's not necessarily a bad idea. It just didn't happen to be the one that we analyzed, but I'm not sure that. On the other hand, I think we should explore Phobos just to learn about Phobos. I think in itself it's an interesting thing to explore. But you're right, it might be very much worth combining the two. You get another advantage, by the way, is you get quite a bit of radiation shielding if you park at Phobos. You might not be able to do a ship that's quite as large as this and actually park it at Phobos. But there's a lot to be said for it. It's
the caves of Phobos is a new world.
It may very well be. It does look like Phobos has considerable interior voids. Yeah.
A comment and a question. The comment is, this is great because when you do land, people providing you some sort of communications relay, they can continue to use this capability from the surface. The question is, what sort of video feedback are they getting? Is it high definition video, or is it like 1 frame a second sort of thing?
Yeah, actually, we specified high definition television, so it's a pretty high data rate. That was another reason that we needed the truck. I'm not sure if you can see it in the picture, but the truck has the pointable dish antenna that we get a high bandwidth feed to our vehicle, whereas it's too hard to put the rovers and have a high bandwidth feed. Sort of moving clockwise here, so here.
If it keeps spinning to make the artificial gravity, how could you keep it pointed at Earth and Mars like you wanted to?
The antennas are despun.
Yeah.
But yeah, I'm not sure. Yeah, their antennas are actually pretty close to the spin axis, and they are despun, so they stay pointed. Yes.
Did you make any allowances for the pickup to be operated in the semi-autonomous mode, like the MER stuff, so that if you pre-position it 6 months or a year, you could actually drive it to someplace interesting
Yes.
before your astronauts
Yeah.
get there?
They are all assumed to have autonomous operation as well. You don't do anything complicated or dangerous. But in fact, what we're assuming is that we can do our analysis at the site, and I think we've defined a site as 10 meters in diameter. And then at the end of the night, the robots come back to the pickup truck, and then the pickup truck autonomously may drive to another site. Or if there's more to do at this site, the pickup truck stays at this site. But the long distance driving, if you're just driving across sand, it does it by itself. So you don't need a robot here. It's still going clockwise. That makes you next.
Has NASA looked into the possibilities of partially funding the mission by selling models of the wigs or licensing them?
That would be cool. I think probably, yeah.
I want one for Christmas.
Actually, the mini wigs. I wish I had I'd showed the video of the mini wigs because they're even more cute and cool. Probably the royalties for that would probably go to Case Western now. Okay, moving around clockwise still. Sure.
Do they have much of a cargo capability? Could they collect a cache of samples so when people arrive, they don't actually have to go out and look for them? They already have a
Yeah, they do have a cargo caching capability, but mostly the cargo caching is the main laboratory is in here. So we actually have a little bit of field analysis on the human equivalent robots, the rock-arms, but most of the laboratory is back on the main vehicle. So we bring the samples back in order to do X-ray diffraction and wet chemical laboratory, electron microscopy, and that sort of detailed analysis. In fact.
Why would you want to take along the Orion capsule for all this?
Because at some point you want to go home.
No, but why don't you leave it in low Earth orbit at the end of the trip?
Well, then you'd have to break into low Earth orbit. In this particular one, I don't think we break the main vehicle into low Earth orbit. We just drop the capsule off and it goes home.
Oh, so do you lose that whole ship after this mission?
In this particular case, we do. Actually, we don't lose it because it's still in this Earth-Mars transfer orbit. So presumably someday we can go out and pick it up again. But in this particular analysis, yes, it's not a reused main spacecraft. I like reusable spacecraft, but the spacecraft engineering team considers that just too hard to do. Yeah.
So what's the next step? You did this initial study.
Actually, the next step right now, what we're doing is this exact same study. We're trying to do it on Venus. And we just started that study last Monday with trying to figure out what do we need to do to improve the crew vehicle for Venus. What we're trying to do is get some of these ideas integrated into the NASA flexible path, which is what the Augustine Committee had recommended, and what by default seems to be what people are proposing. So we're trying to say, well, you know, we keep talking about doing missions but not go to Mars yet. Well, we can almost go to Mars. We can do some really cool stuff. So we have some pretty good advocacy, relatively high, at NASA Glenn that's advocating at NASA headquarters to do some technology insertion into flexible path. The next actual hardware step is we are trying to put together an experiment to do operation of ground robots using telerobotics from the space station. So we're trying to show the orbit to ground teleoperation. Yeah.
So has this been approved now? You got the funding for this?
Depends what you mean. We certainly don't have the funding to fly anything or to build hardware.
Okay.
We have the funding to do the follow-on study.
Okay.
And when I say we have the funding, we have 2 months worth of funding for the Compass team.
Okay.
We have funding for August and September.
Okay.
And at that point, our funding goes away. We also do have the funding to do the analysis for the experiment that we're talking about, the space-to-ground telerobotics definition, where we control a ground robot from the space station.
Right.
We don't have the funding to do that experiment,
Okay.
but we have the funding to do the analysis to say, what we need to buy, how much it will cost, how many people time, what sort of communications bandwidth, how much power, all of the, getting together a plan.
Is there any interest in driving along a couple of concepts and then that would allow you to go ahead and do the Mars moons? Use concepts for linking on the opposite sides?
We didn't include concepts in this particular analysis just because it's one more thing to design. We've been talking about it for Venus. The Venus orbits turn out to be much harder than the Mars orbits. And again, the Phobos exploration adds levels of complexity that we just didn't have time to analyze. I like Phobos. My personal thinking is that it's interesting enough and also complex enough that you probably want to explore Phobos just in and of itself and not as a part of a Mars exploration mission. But there's certainly room for debate on that, and we've debated it a lot about whether we should go to Phobos or not. And there's a good case for going to Phobos in this mission. So it's I'd say that is not a settled question. It's a question we
We
argue
go to
about.
Phobos separate from a Mars mission? How can you do that?
Separate from a surface mission.
Oh.
So if we're exploring Phobos, we don't have the rock hounds, we don't have the surface elements. We just go to Phobos and explore Phobos. And that's a valuable thing to do. That would be probably number one on my list of things to do is to explore Phobos, because it's such an exciting, interesting place. And it probably has ice in the interior, although that's not known. Sure.
At what point would you want to go and land on the planet itself? After how many years?
Well, as soon as possible. I think we ultimately don't want to send robots, we want to send humans. The advantage of this is that it's a stepping stone where we can do it before we've spent all the time and effort and money to develop the Mars landing and takeoff systems. So it's a question of how much funding do we have? How much support do we have? My hope would be that if we did a mission like this, that people would get very excited and they'd say, look, you're only 500 miles away from Mars. Let's do that last 500 miles and support the full human mission. Realistically, if you're going to design all of that stuff, the entry, descent, landing, habitat, spacesuits for Mars, ascent vehicle, that's going to take some time and some funding. Robert Zubrin may say we can do this in 10 years, it's not a problem, but, well, 10 years it would take at least. It's, a target would be to do the human landing 10 years after doing the HERRO mission. That would be I would love that time schedule if we could first do the HERRO mission, demonstrate this part of it, and then go on to the manned mission in 10 years. That would be a good time in the vein. But it's more of a political and a funding question than a technical
So
question.
how much money would you need for full manned mission to do this, land on Mars and come back?
I'm not sure if I'm the right person to answer that.
Roughly,
The answer that I've always discovered is everything is a lot more expensive than you thought it would be. And I've discovered that a lot, and I don't even understand why that is. So when I do my own cost analysis, it never comes up to what the Compass team says, and what the Compass team says, what I know is that it will be more expensive than that because things are always more expensive. So, I'm not sure if I would even be willing to give a guess. My guess